Good afternoon, morning, evening. I know we have people in different regions listening to this one, so wherever you are, thank you for joining this webinar. So the topic for today, obviously, this is a really hot one for us. It's a market that we've tracked for a long time now. Data centers has always been a pivotal part of our critical power coverage, but it obviously becomes just more and more important as time goes by. We see very high, strong investment, as we'll be showing today, globally in data centers for the kind of advanced AI needs, but also for the kind of data processing needs that we were seeing prior to really the advent of AI. So we already had strong growth. We now see effectively turbocharging of strong growth with some of the activity that we see in this space. We have two of my colleagues here today, both of them experts in the data center space. So Gautam is a director in the team, and he has probably a decade and a half, certainly a decade of experience tracking the data center market, is actively involved with our clients across the globe on the data center industry, representing us at a number of major events. Manoj has authored a number of reports and worked with clients on projects related to equipment, components, and trends around the data center space. So you've probably got two of our top knowledge team within Frost & Sullivan for this. The structure today, we're going to mainly have a presentation. So Gautam has got a lot of content and insights that he'll be sharing with you. Manoj will also be sharing some insights there as well. We will be taking questions as we go through, so please put your questions in the chat as we move through. I will be interrupting the guys a little bit as we progress through this to give them some of the live questions that are coming in. So we're happy to take any questions you've got, so just keep them flowing. Right, so without ado, I'm going to hand it over to Gautam to kick things off. And yeah, I'll be joining the conversation soon. So Gautam, it's over to you to get things started.
Thanks, Jonathan. Hi, everybody. Hello. This is Gautam Jyothi, and like Jonathan said, I head up our data center research, and it's a very interesting topic today. Like I said, like Jonathan said, very interesting time in the data center market. As we all know, it's not a secret. Especially with what's happening with AI and the AI applications, and how that is driving the overall data center infrastructure market. So we'll see a lot of trends and market dynamics around that. So we've prepared a slide deck, and we'll go through the slide deck, and we'll be happy to take questions, as Jonathan mentioned. So I'm going to quickly share my screen and start with the presentation. I mean, it's an interesting space right now to watch, and what we've done, I wanted to, before we head into doing the proper trends and dynamics, I wanted to just take a step back to see how we've sort of segmented the overall the market. So the overall data center market, as we all know, we've split it into the three main classifications: co-location, hyperscale, and enterprise. And of course, the way each operates is quite unique in its own sense. So all of the trends that we'll be talking about today will cover all of these three segments. And hyperscale, as we all know, is one of the key segments which is driving the fastest growth. We'll talk about a little bit of what's happening within the hyperscale space, and also within the co-location space. One of the interesting trends there is now we're seeing a lot of the hyperscale builds being done by the co-location operators in terms of build to suit specific for hyperscalers. And enterprise, I think, even though a lot of the compute is outsourced or is moving towards is being outsourced to either co-location or hyperscale, the growth within enterprise is by itself declining, but it is not going away anytime soon for obvious reasons, for security reasons, compliance, and other reasons. Enterprise, on-prem, data centers will still, keep be one of the segments, but in terms of the growth rate, we're seeing quite, lower growth rates in the overall enterprise segment. Now, having said that, it's also important to look at how the overall data center infrastructure is segmented or is split. So there's three key elements when it comes to the overall infrastructure segmentation. The first one we have is the IT infrastructure, which, as you can see, is quite a big chunk of the overall investment that goes in. Nearly 60% of the investment is through the IT. Basically, you've got your servers, storage, and network, which comprises the 60% investment, and then you have the physical infrastructure, which is mainly your electrical and mechanical infrastructure. When we're talking about electrical, everything right from your UPS gensets, PDUs, switchgears, transformers, even modular prefabricated data centers would be categorized under electrical. And then mechanical is pretty much your cooling and HVAC. Cooling is about 85% of the overall mechanical. Then the rest of your HVAC is about the rest 15%. And then you have your other physical infrastructure, where we've tried to include all the other physical infrastructure like server racks, rack options, DSIM, fire safety, digital twins, anything other than mechanical and electrical, try to fit it in the other infrastructure. And then we have the other infrastructure, which is essentially your building and shell and aspects around those. So this is just to give you an overview in terms of how we've segmented it and how we look at the market in terms of the overall data center infrastructure as such. Now, more interestingly, if we sort of move forward in terms of the next slide, I want to talk a little bit about the overall investment, the overall playing field, if you will. So as of now, the overall investment in the total market in 2023 was 300 billion, and in 2024 around 325 billion. Now, what this number signifies is basically the total investment, the added up for the three segments, which is co-location, enterprise, and hyperscale. Put together, we have their capex investment towards data center infrastructure is what the 300 billion signifies. Now, if you look at the overall the growth curve, I mean, from a 300 odd billion market to going to 775 plus billion by 2033, I think for a market of this magnitude, a 10% CAGR is quite significant. And I think also what we see here is a mix of different drivers which would take this market forward. In terms of the first, there's two basic pillars. One is we see the traditional non-AI based workload, the traditional cloud workloads that would drive the market. And now with the AI applications, the AI based workload, that's the driver which is going to significantly push the market towards really high growth rates. There's going to be two prime drivers in terms of driving the overall the market segment, and like how I like to call it is the foundational driver would still be your traditional non-AI based cloud workload, which will keep driving the market, and on top of this would be the AI based workload, which would be a complementary driver, which is still quite significant, and both of these will keep driving the market in the near future. And I think having said that, we also wanted to highlight some of the key trends that will shape up the data centers of tomorrow. We've highlighted 8 trends here, and some of these trends might seem a bit obvious, but still quite important to highlight, because in terms of the severity of these trends, it's getting the impact of these trends is getting more severe as we move through the years. Sustainability, it's been a key trend, like I said, for some years now, but the intensity and severity of this trend has become quite high. I mean, it's to an extent where it's pretty much being placed as one of the top, focus and priority areas for data center operators, especially hyperscalers down to tier 1, tier 2 co-location operators as well. And it's fair to say that it's definitely taken center stage. Things like sustainability backed financing is an emerging trend, and we're seeing a lot of activities around how do we then move from traditional ways of implementing sustainability initiatives to a more novel novel look at sustainability. We'll talk about that in the coming slides. Some of the other trends we've highlighted: energy storage, obviously the lithium ion era, especially for the UPS battery. Battery performance for UPS is a key area that everybody's looking at. And while historically lead acid batteries have been the preferred choice, we're moving towards technological advancements within the let's say the EV industry, or even the overall advancements in the EV market and the battery market, is making lithium-ion batteries a quite a highly viable alternative, both economically and technologically, I would say. Hyperscale, the growth of hyperscale is an absolutely important trend. I mean, the rate at which hyperscale investment is growing is just tremendous. We'll see more details on that in the coming slides. Advanced cooling, it's an important one to call out. It's gaining momentum, especially as we know, is driven by the AI wave. Two aspects to this. One is a rapid shift towards, let's say, liquid cooling to address the high density AI applications, and then on the other side you have the how do we leverage AI and ML to optimize cooling. We'll talk about this in a bit more detail in the coming sections. Other things such as market consolidation. It's been the golden era of data center M&As and JVs. It's at an all-time high. We're seeing that even not just among the data center operators, but even among the infrastructure solution providers. I mean, cooling, data center cooling is a very good example of that. We'll see that in a bit later in the section as well. Edge computing, again, and not a new trend, but it's been there for a while, and especially things like AI and the advent of 5G will further drive compute closer to the end user. And of course, just AI. How do you use AI to optimize the overall performance? Again, two aspects to this: AI to optimize operations, and how AI applications would drive the future design of a data center. So those are the two aspects we'll cover in a bit more detail in the coming sections. The first one, I've picked a few trends to do a little bit of a deep dive on, and in that sense, the first trend I want to talk about is sustainability. Like I said, I mean, to put things into context, in terms of the overall the greenhouse gas emissions from data centers is actually around 2%, a little more than 2%, which is almost the equivalent to the airline industry emissions. And this is why it's such an important topic on top of mind for data center operators. Now, some of the metrics that we see here, PUE is still a very important metric, but we are seeing a shift, or the focus shifting towards other metrics, such as you have carbon usage effectiveness, water usage effectiveness. All of these metrics are more looked at a more serious level. Still keeping PUE same importance, but they're looking at other metrics, and the focus is shifting towards those metrics as well. And in terms of some of the next frontiers, or what are some of the emerging best practices outside of the traditional approach of, let's say, focusing on energy efficiency, basically trying to move towards more sustainable construction strategies. How do we look at waste stream accountability, circular economy being integrated into it? Water conservation and management, that's a really important one. We're looking at elimination of diesel gensets, things like how do we incorporate fuel cells, on-site power, energy storage, and waste heat reuse, again, is an important one. It's got a regional trend to it, but still nevertheless an important aspect to consider when it comes to the next frontiers. On the other side, when we look at the end user perspective, and what are they looking to do and consider, so they're quite keen about innovation sort of in energy and power, mainly to look at how do we optimize the efficiency and the cost of the power consumption, and things like innovative procurement models for green power, cutting edge service delivery models to complement sustainability efforts, and the likes. Now, very close to that would be how does economies of scale play into it? So considerations around economies of scale, especially pertaining to sustainability in data centers, is quite increasing significantly, I would say. And this is even one of the primary drivers of change, which is in fact accelerating the outsourcing rate of enterprise class data centers. And again, from regulations and a standards perspective, there's a lot happening, in terms of the environmental standards and codes pertaining to the infrastructure and operations. As of now, a lot of these are optional and voluntary, meaning these are mandatory, and data center operators incorporate these standards as a measure of best practice to promote energy efficiency. Having said that, we're seeing quite an increase in the regulatory pressure, especially in the European region, which I think will play a key part in the overall scheme of things. So that was the sort of key dynamics around sustainability, sustainability and decarbonization. Now, the second trend I want to sort of do a bit of a deep dive on is advanced cooling. Now, we all know data center cooling accounts for nearly 35 to 40% of the overall power consumption. And so what does that mean? And in terms of overcooling is an important issue, and a challenge that is basically what we see here on the right is the PUE chart. What we're seeing is the PUE levels have plateaued over the past many years, and we're seeing a lot of demand for advanced cooling that would actually help address these issues. For instance, how do we leverage AI to optimize cooling efficiencies? How do we monitor? How do we analyze and further optimize the overall energy and the power that's needed for the cooling system? In essence, how do we apply the right amount of cooling where and when it's needed among racks, so that we optimize cooling, and this way we use the AI system. If you see the chart on the right top corner, that's essentially an AI system calculating the required adjustment in airflow to basically maintain the correct temperature for each aisle of the rack, and basically making adjustments autonomously without human intervention. So there are quite a few value drivers. Of course, the reducing cooling costs, optimized cooling performance, which results obviously in a better equipment health, and reduces the risk of failures. Ultimately, reducing the downtime, maintaining optimal temperatures at equipment level rather than a room level, then react to ability to react to sudden erratic shifts in demand. So there's quite a few interesting aspects that is pushing the adoption or the way advanced cooling is penetrating the market. And the next aspect when it comes to we talked about AI, and so in this particular slide, I wanted to highlight some of the trends around what exactly would be the impact because of all these AI solutions and AI workload. How are data centers being designed to accommodate the AI applications, or to host the AI workload? The first one we're seeing is, in terms of the overall impact, the increased power density and cooling efficiency. So essentially, AI powered data centers, we all know, require much higher computing densities, which mean more efficient cooling systems than the traditional data centers. So we're seeing a lot of activity around direct to cabinet or direct to chip cooling, which are some of the most popular options to remove heat. And these innovations basically optimize heat dissipation, improve energy efficiency, and ensure operational viability of AI-specific data centers. And then what we're also seeing is, in terms of equipment redundancy and the architecture, most of the AI models, we are seeing that they don't require the same level of availability and uptime as the cloud. So this will prompt data center operators to essentially rethink redundancy strategies, especially on electrical infrastructure such as UPS and gensets. And high densities associated with AI will ensure a decrease in the number of racks per row, and optimization of data halls. And also, we are seeing, when it comes to how do you optimize the mechanical and electrical infrastructure, so what we're seeing is the data centers and even the design build firms are using architecture. They're moving away from the traditional approach of, let's say, designing box solutions for mechanical MEP solutions. And there's also a high focus on using less carbon intensive material. And they're in terms of the even placement of the mechanical and electrical infrastructure. They're focusing on even optimizing server placement, and the whole aspect of designing a data center is moving more towards modular solutions and prefabricated modular solutions that actually offer a high degree of scalability, flexibility, not just from a mechanical or an electrical perspective, but also the overall build of the data center as such, which is your prefabricated modular data centers in terms of the overall the structural aspect of it as well. And in terms of the basically the enhancing the data center design and efficiency, we're seeing a big push among operators and even data center consultants to deploy innovative solutions in terms of the overall data center design as such. A big component of this is leveraging AI to optimize DSIM, the overall operations. How do you build one single pane of glass view to optimize the overall operations? Main area of impact would again be things like power optimization, cooling optimization, even server optimization, workload management, and all of those would be inclusive of that. Now, on the last deep dive I want to do is on the growth of the hyperscalers, which we talked about earlier. So what do you see here on the left side is the chart on the left hand side shows the top 7 or 8 key hyperscalers. If you look at the investment that went in for data center infrastructure by these top 8 hyperscalers, accounted for $101 billion. And this number is only significantly increasing as these hyperscalers cater to and invest towards hosting AI applications and AI-based workloads. So it's a very interesting dynamic to see that the level of investment by these hyperscalers is playing a very crucial role within the overall data center infrastructure market. And as you can see on the slide to your right, what we've tried to highlight here is a split between the overall investment by these 3 segments. And of course, still enterprise is a big part of it, even today. But that share of enterprise with 47% in 2023, that's going to decline as we go through the forecast periods. It's going to come down to potentially 32% over the next 10 years. But enterprise will still then be an important segment to cover because, like I said earlier, there are still aspects which would prompt the on-prem data centers and keeping the workload on-prem for enterprise data centers to an extent. Having said that, I'm going to pass it on to my colleague Manoj, who will comment on some of the next slides, which will take you through some of the segmentation split, and some of the market numbers as well. Having said that, I'm going to pass it on over to Manoj. Over to you, Manoj.
Thank you, Gautam. A very good morning, good afternoon, and good evening to people joining us from different parts of the world. My name is Manoj, and I'll be taking you through the next few slides. So Gautam did explain to you the investment parameters and how AI is affecting the investment market and how things, basically data center architecture revolving electrical, mechanical, that is cooling and power, will change once AI becomes the norm in data centers. So I'll be talking about physical infrastructure investments, a little bit on cooling, and we'll touch on power and the key companies and what they are doing in the market to stay ahead. So as you see, if I see this slide, most of the investment in data centers, this is global, cutting across hyperscale, be it co-location, and even edge data centers and enterprise one. Most of the investment in physical infrastructure goes into the electrical ones, that is the gensets, UPS, the transformers, switchgears, and so forth. Still, they form the majority of the investment. Nearly half of the investment goes there. Mechanical is where we talk about cooling, the HVAC systems, and the other systems that keep the data center from heating up. So this is where most of the investment will focus on the future. Right now, it's 27%, but it will grow as AI cooling requirements grow. This is where we will touch upon liquid cooling and immersion cooling as we come across. So most of the focus will be on the electrical infrastructure part for now, but we will see the mechanical infrastructure involving cooling will grow in the future. Other infrastructure, as we said, mostly land building and other components will also be part of it. But majority of the infrastructure investments will revolve around electrical and mechanical in the future. Not only 2023, but going forth, cooling will form a very big part of it as AI and the servers that require AI and the data center architecture takes a complete changeover. So next slide, please. Here we talk about the cooling and HVAC systems. What we see within the mechanical cooling infrastructure space is cooling forms a large part of it. Gautam already touched about cooling forming 35 to 40% of the total power resource. Why we are focusing on cooling is majority of the data center operators look towards cooling as a large power guzzler, so to speak. So large corporations like be it a Google or an Amazon have large hyperscale data centers which have enormous cooling requirements. This takes up a large part of their power. Most of their power right now is being consumed from renewable energy, mainly supplied from the grid, some on-site power generation. Most of the focus is on the cooling solutions because they want the new age servers and new age GPU processors to remain cooled and to process 24/7. So they do not want any downtimes. So cooling solutions are on the foremost list for most of these data center operators who keep a very good priority for cooling solutions. These cooling solutions can take over from the normal ones, that is the normal air conditioner ones, which were there in the older data centers, to in-row, in-rack cooling ones that came in between the data center evolution, to the latest ones, that is liquid cooling or else immersion cooling, or that takes cooling directly to the chip. So you will see most of the infrastructure investment for mechanical infrastructure is still focused on cooling solutions, which are getting advanced by the day. Here you will see a lot of focus being put on taking cooling directly to the chip so that they can remove the heat much more efficiently. And as mentioned before, they want to optimize the entire process so that the airflow investment that they are doing and the airflow pathways that they are designing work well, and they are able to remove the heat without any disruption to operation. Disruption to operation is one of the reasons why cooling is in focus, because downtime is one of the things that most data center operators want to avoid. We also see that most of this cooling is moving away from traditional solutions to the more advanced ones. We see a lot of chillers being placed. We see a lot of in-row fans also being used, but we will see that a lot of the focus of many of the companies that are there is focusing on the next generation solution. That is, how do we use direct to chip liquid immersion cooling to remove the heat. So most of the investment will be focused on main cooling solutions. Other HVAC solutions and other related infrastructure will also be part of it, because that is the main thing that drives the entire cooling architecture, like heat pumps, like storage, piping, control equipment. But majority of the focus of data center operators is cooling. I would say that apart from the servers and the servers and the IT equipment that they are investing in, the next most important investment they have is cooling, which determines the operations of the data centers, which determines the downtime, and which determines the operating conditions in which they need to put the IT hardware in. Next slide, please. Here we talk about the data center cooling market. This involves all types of cooling technologies, be it traditional cooling solutions, be it the more chiller types or the in-row, in-rack types. You'll also see that most of these solutions are graduating towards the higher and advanced cooling solutions, especially when AI data centers take over. Once AI takes over, we will see a rapid increase towards the advanced cooling solutions. This is not to say that traditional cooling solutions will disappear. Traditional cooling solutions will always be there because there are a lot of smaller data centers, a lot of legacy data centers in the enterprise class, and there are a lot of data centers who are hesitant to move over to the new technologies and change over their architecture. So you will find the current ACs and the current chillers still being there. But what we are trying to say is we will see a lot more liquid immersion cooling solutions. We will see direct to chip heat exchangers, and we will see a lot of transformation in data center cooling architecture. Having said that, we see the market right now around 10 billion, 10.5 billion for 2024. And this is being a high growth market due to the various investments that we have said previously. This market will go on to be nearly a $30 billion market by 2030. This high growth is being driven by massive investments, driven by hyperscalers who are investing records amount of money into AI-driven data centers and AI-driven processes. There is a global competition going on for replacing the entire data center architecture with GPUs so that they can do parallel processing and drive higher efficiency for their products and services. This will need more cooling solutions and more advanced and efficient cooling solutions, which can remove the heat directly without any compromise on safety, without any compromise on downtime. So most of these data center operators, if you are seeing, their capital expenditure is growing at double-digit level, not at single-digit, but double-digit level, and this will keep on growing. Based on this double-digit investment, the requirement for cooling solutions will also keep on growing because most of the data centers are also becoming large. Most hyperscale data centers will be about 10 megawatt in the next couple of years. Right now, 5 to 10 megawatt was what they were starting off with, but most of them will be about 10 megawatt. We also see 100 megawatt to 200 megawatt centers coming up. So these are large scale facilities which will require extensive cooling solutions. And most of these data centers will also incorporate multiple cooling solutions, not a single one. You will have a mix of the traditional one also, but you will see the movement towards advanced cooling solutions, which can completely take care of itself and remove the heat completely from the data centers. So this is a high growth market with high CAGR because of the current boom in data center investments, mainly driven by AI systems that are being deployed every day. So these systems are modern systems which are getting traction, and more AI infrastructure that is being developed across the world will require more AI data centers for processing and data storage. So this directly impacts the cooling market, which automatically becomes a high growth one going forward. So next slide, please. This is where I was talking about the traditional versus the advanced one. Right now, if you see in 2023, the traditional crack and crawl units form 60% of the market. Why is this? Because most of the legacy data centers are still with the enterprise ones, still with the co-location ones, and a little bit of the hyperscale ones still use the traditional crack and crawl units. But if you see, there is also the other three solutions. There is the high density cooling solutions that are currently used. You have the chillers and airside components. You have the advanced solutions. Where I would like to focus is on the advanced solutions. Right now, it's 14% of the market, but it has grown up from a very low base to 14% of the market in the last 5 years. What we see is advanced cooling solutions includes direct to chip, but also liquid immersion cooling. Liquid immersion cooling is gaining traction because of large investments by hyperscalers. Hyperscalers like Google, Amazon, or even Oracle are trying to move large solutions into their data centers. This is AI-based processors and completely moving the data centers from traditional IT architecture to AI-based architecture. This will require a complete changeover in the cooling solution. Mainly liquid immersion cooling is what they are experimenting with. Many companies such as Alphabet are directly working with vendors, and we will see in the next few slides which companies are. Many of them are directly working with vendors to produce bespoke solutions for their own data centers. This is mainly into liquid immersion cooling solutions, which is right now we estimate 8 to 10% of the market. That is around $900 to $1 billion. But the growth rate is expected to be high because most of the traditional cooling solutions deployed by these hyperscalers will move into a liquid immersion cooling market over the next 5 years, because the demand for liquid immersion cooling and the efficiency with which it removes heat and it allows the operations to continue 24/7 allows the companies to deploy these solutions. Most of these solutions are bespoke, as I said before, and they are manufactured along with the guidance from the hyperscalers themselves. Most of these solutions are operated by the companies who provide the cooling solutions, meaning some of the companies who provide the chillers, who provide the in-row in-rack solutions, or even the crack crawl units are moving towards advanced solutions because they see a high market growth rate. This is where the market is expected to grow high exponentially. Though I would like to point out the other markets also have high growth rates, but the exponential growth rate that is about 30% is being in the liquid immersion cooling, that is the advanced cooling solutions, mainly driven by hyperscalers. I would like to point out that once the hyperscaler market catches the wind of, say, liquid cooling, the co-location market is also the next hot market for advanced cooling solutions. We are already seeing that the co-location market move from the crack crawl units or the chillers or the in-row coolers to directly to liquid immersion cooling. The new generation co-location players are also becoming in a sort of hyperscalers. They are deploying above 1 megawatt data centers in some places because the demand is so high for AI-based infrastructure. This makes them depend on advanced cooling solutions. So the new generation of co-location ones are moving towards advanced cooling solutions. And in the future, you will see that old and the traditional ones will also move towards advanced solutions. This is not to say that the crack and crawl unit will reduce. It will still have a large market share because the legacy market of enterprise is still there. But we see advanced solutions penetrating across all the markets, including the edge market, which is a small market coming up with 5G telecom and 6G telecom solutions over the next decade. Next slide, please. This is what I wanted to point out. This is where we have seen a lot of liquid cooling companies that are coming up. On the left, you see a long list of the key liquid cooling companies across the globe. You see names like Airsys, Acitec, Cool IT Systems, DCX, Green Revolution Cooling, Isotope, Submer, and Zutacore. This list is a long list, and you will see a lot more innovative companies coming across in this market. Mostly starting off with North America and Europe, these companies will penetrate towards the Asian region, mainly the East Asian and the Chinese market, where the hyperscale and the co-location growth is there. We see a little bit of growth in the Australian and the Middle Eastern segment also, but most of the liquid cooling companies will come from the North American and the European solutions because they have the key technology one, and they are also partnering with key equipment providers, that is the traditional cooling solution providers, as well as the IT equipment providers, because in most cases, the IT equipment providers decide the cooling solutions that goes into their servers, their microprocessors, and so on. Also, they partner with hyperscalers, like some of them are partnered with Google, some of them are partnered with AWS, in order to gain access to the market. So if you see on the right, we would like to point out the notable industry partnerships. Like Vertiv is a key cooling solutions provider. It acquired one of the CDU manufacturer because the move towards liquid cooling is very high. You will see likes of Schneider, which is a very big cooling solutions provider, also acquired liquid cooling firms like Motivair. You see several private equity players like Cool IT Systems being bought over by KKR. Because the growth rate in this market from a low base is very high, this represents a very good investment opportunity even for private equity firms and private capital. You also have smaller firms like Green Revolution Cooling who are collaborating with Japanese players in order to develop new solutions. You also have Vertiv, which partners with NVIDIA in order to design the liquid cooling solution in work with their new latest GPU chips. So in this case, what happens is NVIDIA will decide what type of cooling solution is best for their next generation processors. So this helps the equipment providers to develop bespoke solutions that goes into the data centers. That's why you have the likes of Acitec working with HPE, and you have Cool IT Systems working with Dell. You have a lot of providers like Huawei also working with Submer because this is a global phenomenon. Most of these companies are small and niche companies, but they have a wonderful technology, and they're partnering with traditional players and with hyperscale operators and with processors and IT equipment providers in order to develop those bespoke solutions which fulfill the need of AI deployment in data centers. AI deployment data centers will radically increase the power demand of data centers. Some reports say it takes up to 3 times the power that is currently required. Hence, the cooling requirement will also be that enormous. In order to cater to this, you will need more bespoke solutions instead of a generalized solutions, which can drive not only efficiency, but also remove the heat and avoid downtimes for large processes. This is what most data center operators want. They do not want downtime and increase efficiency of cooling, because cooling is a large part of their power consumption, nearly 40% in some cases. So higher the efficiency of cooling, higher will be the efficiency of the data center operations. So in the future, you will see data center operators directly partnering in a 3-way setup, directly partnering with the GPU providers, also with the equipment providers who can provide them with liquid or any advanced cooling solutions which can match their needs. So this is how the market is expected to go over the next 10 years when this AI boom is supposed to pick up and take place. Next slide, please. This is a slide where I would like to touch upon the UPS market. Generally, UPS market is part of the backup systems, part of the data centers. As I was talking about the power being a large part of the cooling market, nearly 40%, need for backup power systems is also crucial because most of these data center operators cannot afford downtime. Most do have large backup data centers also, but they too require multiple backup systems. If you were to see the data center architecture, they do not deploy a single backup solution, multiple backup solution, with the traditional UPS being the key one. We see a large part of UPS market growing from about nearly 4 billion to doubling to 9 billion and above by 2030. This is because of the next generation UPS that's coming in. Most of these UPS will be modular, highly scalable than the traditional ones, which were not that modular. Most of these data centers will also deploy lithium ion based UPS solutions, moving away from the traditional battery solutions. So you'll see a large scale UPS deployment to cater to the increasing power demand, that is mainly backup power demand. And this is more prone from the Eastern world than the Western one, because if you see, majority of the hyperscale of the large scale data centers expected to come up in Asia over the next decade. This will drive the demand for more UPS power solutions as power generation and power lines are erratic. And this will drive the UPS market in a similar growth rate to the cooling market. So power and cooling are two key features of AI deployment in data centers. And this will be the key growth markets for as long as AI gets deployed in the data center market. I would like to pass on to Gautam now for rest of the presentation. Gautam, over to you.
Just to say, Gautam, just to interrupt, we're running close to time. We've got some questions, so if you can wrap up pretty quick, that'd be great.
Sure, will do. Thanks, Manoj. Thanks, Jonathan, for the time check. Now, just as an extension to what Manoj was talking about in terms of the UPS, again, bringing it in terms of the context of what AI is doing to the overall backup power. In terms of, again, it's when we talk about some of the strategic trends around the backup power market, the UPS market. Essentially, it's evolving from a plain backup to a more of a resilience platform. So UPS, I would say, is no longer just like a fail safe. In AI rich, AI heavy, sustainability focused deployments, it has become a programmable and rather an intelligent layer within I would say, the digital infrastructure stack. So what we're seeing is, in terms of data center operators are looking for how do they use, how can a UPS help reduce downtime, but also at the same time, enable autonomy and support things like, grid innovation and grid support. Essentially, not just delivering backup power, but also doing all these other bits and pieces to support with the AI evolution. And the UPS vendors who basically position UPS as a part of the orchestrated infrastructure layer are going to gain a more strategic preference. And just to highlight some of the key trends and shifts. So in terms of obviously the AI workload, we're looking at UPSs that are able to support higher densities, faster switching, because with AI workload, AI and ML workloads create sudden and dense power draws, especially in GPU rich, let's say, training clusters. So how are UPSs being designed to cater to that? And in terms of modular blocks, how do they support, how do we deploy UPSs that support space and budget constraints, even in edge and co-location environments? So these are driving the modular UPS systems forward. Renewable integration is something that operators are pursuing, in terms of hybrid energy strategies, integrating solar, PV, fuel cells, battery energy storage. How does a smart UPS system then act as a gatekeeper between the data center and the grid, enabling sort of energy arbitrage and load shifting and things like that? And of course, we were looking at things like intelligence, embedding intelligence and monitoring. So data center operators want UPS visibility embedded into the broader digital infrastructure management stack. This includes your DSIM, power monitoring, thermal control systems, and all that. Features like real-time, battery scoring, predictive fault alerts, autonomous runtime, optimizations, basically shifting, from being differentiators to base level expectations, let's say, especially within the hyperscale environment. And again, within the battery technologies, we're witnessing a shift away, like we talked about earlier, from the traditional lithium ion traditional lead acid to lithium ion, and even lithium ion phosphate. quite a lot is driven by the ESG pressure. When it comes to the operator, behavior shifts. So to data center operators, redundancy is no longer just about, capacity over provisioning, let's say 2N or 2N plus 1. It's more about, the intelligent distributed autonomy where, for instance, power zones can isolate, reroute, and even self-heal. So how do we then deploy a UPS system that caters to all of these, micro segmentation and even workload switchover, especially in a modular, AI environment. So yeah, and also operators are, on the purchase decision, on the life cycle cost is more the direction, which includes installation service, battery replacement, energy use, integration complexity, and all of that. So capex alone is no longer a key decision making driver. You're looking at the overall costs in the larger scheme of things. So even in terms of the overall UPS and the backup power environment, the role of AI is going to be quite significant in terms of how UPS systems are being designed and deployed across the data center segment, where the biggest impact area is going to be felt the hyperscale segment, slowly trickling down to the tier 1, tier 2 co-location operators, with the lowest impact being felt in the enterprise class segment. Having said that, I realize the time, we're running out of time.
It's definitely time, Gautam.
Yeah, I'm going to stop there. I'm going to stop there. I'm going to pass it on to
you've had more than you could.
Jonathan.
Thank you to both of you for that. I've got a few questions. I've been saving a few as we went through because I wanted to get into them right now. So the first one we've had in on the impact of AI on data center infrastructure. Can you comment on the specific impact on how the next gen data centers are to be built to cater to both AI-based and non-AI based traditional workload?
Right, I can take that. It's a very interesting, I would say, observation or a comment or a question, because obviously what we're seeing is, and when it comes to AI workload and non-AI workload, as of now, I would say over 90% of the AI workload is being hosted in the hyperscale environment, which begs the question: how are these future, or how are the next gen hyperscale data centers are being built to cater to this existing demand of your cloud workload plus the top of the AI workload? The answer to that is it's going to be a hybrid environment. So what we're seeing is data center operators are designing their data centers to help cater to the traditional workloads plus the non-traditional workloads in the same environment. So how do they do it? In terms of the biggest impact area there would be on the type of cooling solutions to be deployed. That's the biggest impact area. So when you build a next-gen data center that could host both AI workloads, which are talking about 100 to 200 kilowatts per rack level of densities, and then you also are looking at 12 to 15 kilowatt per rack, which is your traditional cloud-based workload. How do you then bring these two together? Which means you have to have a combination of your liquid cooling setup plus your air-based air cooling setup. So the biggest impact area for this, I would say, would be on the mechanical side, where we are seeing already, these data centers being designed and built this way to support the hybrid environments of liquid cooling plus air-based cooling in one single environment. So the hybrid approach would be the answer to that, Jonathan, to be able to cater to both simultaneously.
Super, thanks a lot, Gautam. I also have another one on data center cooling. So what would you say are the key liquid cooling technology segmentations, a bit more on the growth of these, and specifically on direct-to-chip and liquid immersion cooling?
Right. So, I mean, Manoj talked a little bit about the overall segmentation between the CRAC units, the traditional cooling, and the liquid cooling. And like Manoj highlighted, as of now, it's a small segment, the liquid cooling, but it is. So we saw that around 17% was the overall growth rate, the CAGR projected for the overall data center cooling market. But if you separate out the traditional cooling and the liquid cooling, we're seeing the liquid cooling will be about 30 to 35% CAGR in the next 7 or 10 years. And the question, I suppose, is within liquid cooling, what are the segments you're seeing? So I think, broadly speaking, you can split that into two key types, which is your directed chip and liquid immersion. And as of now, what we're seeing is the market is quite skewed, or is quite concentrated towards the directed chip type segment, which is at the moment in 2024, I would say accounts for about 65-70%, even more than that, more than 70-75% of the overall market. And the rest would be the immersion cooling. And in terms of growth rate as well, we're seeing really high growth potential for directed chip. And within directed chip, I think single phase is the more prominent segment, or the technology subsegment. We're also, so there's going to be a pivot, which is in the next maybe 3 to 4 years, you're going to start seeing the penetration of liquid immersion to be more prominent, because again, that will be driven by the increasing power density. So at one point, I think when we're already talking about 200 plus kilowatt per rack. So when that goes to 300 or 400 kilowatt per rack, that's when immersion cooling gets more feasible. And I think also by then, as of now, liquid immersion is a niche technology. I wouldn't say not proven, but yet there are a bit of a level of skepticism around the technology and the maturity. So that's going to be, all of that will be sorted out in the next 3 years. So that's when we'll start seeing a pivot towards immersion. But not to say that directed chip will not keep growing; it'll still keep adding to the pie. But yeah, that would be the segmentation for liquid cooling, Jonathan.
We've got another one here talking about modular data center trends. How do you see the modular data solutions evolving in terms of future growth potential?
Oh yeah, without a doubt, it's going to be a key space to look out for. Like I said earlier, the one thing about modular prefabricated data centers is that the perception, that is, was that it was only suitable, or it is only suitable for small scale deployments. But that's changing now in terms of the innovation and the technology advancement that's happening within the prefabricated modular data center space. These solutions are quite feasible even for larger scale deployments, and we're already seeing some of the larger scale deployments based on prefabricated modular solutions. So really high potential, quite a high growth rate. I would say close to between 15 and 20% CAGR. But yeah, so we've been seeing modular deployments for tier 2, tier 3 co-location providers, but now we're seeing a lot of the tier 1 co-location and even hyperscalers being quite prominent on adoption for modular data centers.
We've got one as well from LinkedIn Live, so separate from that. And it's essentially someone who's basically saying, what are the trending areas that mechatronics can get involved in to help energy shortages in the world? So it's quite a broad one. Mechatronics is essentially where you're bringing together, for those that don't know on the presentation, it's where you basically bring in engineering, mechanical engineering, electrical engineering, as well as computer science. So I suppose if I can frame the question a bit differently, maybe what are the potential roles for industry professionals within AI in data centers? Is there more demand for people behind all this? Is it moving more towards people being irrelevant and it largely being the technology dominating things? I mean, where do we see maybe the human in all of this in data centers?
Yeah, I'll have a go. And I mean, the human element is not going away, right? I mean, we can, or we will never remove the human element, whatever be the case. We will still need a human element to be able to control whatever's going on within the data center, be it the operation side, be it the build side, whatever that is. But I mean, it's from a mechatronics perspective, I think it's a very interesting point, because the key things with remember the initial chart that I showed, which is 3 segmentation, you got IT infrastructure, and then the physical infrastructure and the other infrastructure. So the entire chunk of the other infrastructure, it's a combination of mechanical and electrical. So when you bring these things together, and there's a layer beneath both these, which is the visualization layer or the orchestration layer, where we call the DSIM, and you have how all the software elements fit into then monitoring your electrical components, mechanical components. So what they're suggesting with the question is, I think that's got a really bright future. So this is pretty much bringing in these elements together, which is exactly what already you're seeing, in terms of DSIM 2.0 with the homegrown software elements that try to make these components talk to each other. So I'm not an expert at mechatronics, but I suppose it's got a really good future.
Great. Okay, thank you. We're going to have to stop there because we're pretty much on time. I thank you both for your insights. I thank you to all of those who asked questions. yeah, thank you to everyone who joined and listened in. The link will obviously be available, and you know, if you have further questions, please reach out. You know, and if you interact more, we're more than willing. So thank you everyone for joining, and thanks for your time today.